In this video, we will review 5 questions that cover target 3C. We're going to start with question number 1, move on to number 2, number 3, number 4, and this one is number 5. So back to question number 1, and we are given an A, B, C value, and we need to plug those 3 values into our quadratic formula. That's it. We're not going to solve. So what I do first is just rewrite my formula, but without my A, B, and C values. There we go. So now I'm going to go back and I take my A value, which is 7, and I plug it into the A values in our formula. So we're going to put a 7 here and down here. Then I go to my B value, which is -1, and we have to put it in front there and then right there. So -1, -1. Lastly, our C value is just in one place. It's at the end, and that was 3 actually. So let me highlight that. There goes that. And that's it. So we don't have to solve. Question number 2, we're given an equation, and we got to figure out what A, B, and C are. So now it's important to know that the A is just in front of my x squared. It's a part of the quadratic term. It's the coefficient of the quadratic term. So the number that is in front of the x squared term here is 2. So A is going to equal 2. And then the B value is the number in front of the x. It's the coefficient of our linear term. So the number in front of our x is 16. So that's going to be 16. And then lastly, our C, that's the constant. It's the number by itself. So -5 is by itself. So we're going to write C is -5. And that's it. Question number 3, we have to identify our A, B, and C. But it's important to note that we have to set our equation equal to 0 first. So let's get rid of this stuff from this side. That means we're going to take away we're going to take away 7x, and we take away 9. So those both cancel out, and we get 0 on the right side. We also have to do the same thing to our left side. So if we combine all these like terms here, we're going to be left with 4x squared minus 9x minus 5, which equals 0. And then I have my standard formula equation here for quadratics. Our A is in front, the coefficient of our quadratic term. So A will be 4. B is going to be the coefficient of my linear term. That's going to be -9. And then lastly, -5, that represents our C. So our C value will be -5. And that's our A, B, and C values. Our next question, we're given a quadratic equation, and we need to solve it using a quadratic formula. So first we need to set it equal to 0. That means we have to take away 5x, and we have to take away this 4. So there we go. That 5x goes away. This 4 goes away as well. And we're left with the equation set equal to 0, and we have an x squared plus 2x minus 3 on the left side. Then you call out your A, B, and C values. A is in front of the x squared term, which would be an invisible 1. 2 is in front of the x term, and -3 is the constant. Then we set up our quadratic formula, blank. There we go. And then we want to plug in our A, B, and C values, just like that. And now we want to start simplifying. So I'm gonna start off by writing x equals, and then we have a -2 in the top left-hand corner here. Then we have plus or minus, and I'm going to simplify everything underneath this radical here. So we have a 2 squared. I'm going to write 4 then, and then we have -4 times 1 times -3. That actually gives us a +12. So be careful with the sign change there. That's all underneath the square root or the radical. If we add 4 and 12, that gives us the square root of 16. And if we take the square root of 16, that gives us 4. So really, what I'll put up here in the top right hand corner is just 4. And then on the bottom, 2 times 1 is just 2. And the one thing I always recommend you being careful for is how you simplify everything underneath this radical. Sometimes some people mess up some of the signs here. So moving on, we have x equals -2, and we have to split this up into two parts. So we're going to do +4 first, divided by 2, and then we have another version that's going to be x equals -2 minus 4 divided by 2. Simplifying a little bit more, -2 plus 4 is 2 divided by 2, and then that gives us 1. So x equals 1. Up here we have -2 minus 4, which gives us a -6. We're dividing that by 2, which gives us a -3. So the other x value will be -3. So we're going to have two solutions here. And on to the last one, our fifth one. It's similar to the fourth one, but we already have an equation set equal to 0, so we just call out our a, b, and c values. There we go. Remember that a is in front of the x squared, b is in front of the x, and c is the constant. Now I'm going to write a blank quadratic formula, just like that, and I'm going to plug in my a, b, and c values, and I'm going to start simplifying. So we have x equals, we simplify this part up here, this top left part. If we have a negative times a negative, that becomes a positive 3, plus or minus. I'm going to simplify everything underneath this radical, so -3 squared gives us 9, and then -4 times 2 times 6, -4 times 2 times 4 is going to be, what, -32, -32, that's all going to be under the radical. 9 minus 32 is going to be a -23. Again, that's underneath the radical. And we don't like negatives underneath the radical, so we split up that radical by saying the square root of -1 times the square root of 23. And that square root of -1 becomes an I. And then we still have the square root of 23. So that's what we're going to take and put all the way back into our problem. It's going to be I times the square root of 23. That's all divided by 2 times 2 up here is 4. And that's going to be our final answer because we can't combine any more terms. We can't reduce anything here. And we cannot add I times the square root of 23 to 3, which is not like terms. So this is going to be our final answer. So let's go back and recap. We started off with a problem where we are just plugging in our a, b, and c values into the quadratic formula. The second one, we had to identify a, b, and c. Third, we had to identify a, b, and c, but first we had to set the equation equal to 0. Number 4, we are solving using the quadratic formula. And the fifth one solved using the quadratic formula, but it was different from the fourth because we had an imaginary number over here where we couldn't separate it into two different parts. We just keep it all together like that.